Hi guys, it's Steve again. I was going to start my tutorials on MIM, and this is the setup I've came up with to help everybody learn and understand how to use MIM. If you look at the screen, I have two QB64 programs up and going, left and right, one beside each other. This is so I can showcase the similarities between MIM and some existing commands that most people already know. It should help make it easier to understand how to use one if you know how to use the other. Now, don't pay any attention to my screen image and screen move. These statements are just up here to help position the output. Compile the file, and it pops a window right up above it. This one will pop a window right above it. So when I do compile, so you can see what we're doing, the two outputs will be right above the windows and easy to compare as well. So the first thing one needs to learn before learning to work with MIM is simply how to use binary files. If you can open a file for binary, you can work with MIM. It's not complicated. A lot of people think, oh no, I'm going to dig around in memory and screw something up. Well, you can't. Windows protects you. The worst you can usually get is page fault, your program's crashed, boom, it's shut down. We have to terminate this program. So, as programmers, we're used to having things crash on us and bug out. So don't worry about what could happen. That's the very worst thing that could happen. And QB64 does a fairly good job of protecting you even further than your OS does. Linux, Windows, whichever you're using. They all have a protection to protect from page faults and memory faults, and to protect you from screwing up the system. Usually they just throw a warning, page fault, program termination, and then you say okay, and it closes and it quits. So the worst you can do is have a crash. The best you can do is speed up your programs about 100 times. MIM is much faster because you're accessing the memory directly and you're not going about using it through variables and such, which have to be looked up through a lookup table and then bring the values to you. So for really intensive positions in your program where you need the speed, you want to use MIM. And it's not complicated. Over here on the left hand side, where my cursor is moving now, I'm going to start writing a small program, and I'm going to step by step translate it from binary on the left to how we do it in MIM on the right. The first thing, when you're working with binary files, you need to know a file handle. F equals free file. This says that we're going to have a file handle that we're going to use. Same thing over here, except we dim a variable, dim M, as MIM. That says we're going to be working with a MIM block. This says we're going to be working with a file. File, MIM. Very little difference between the two. Over here we then open a file, temp.txt, for binary, as number F. We use the free file and we open a temp file with it? Well, there isn't quite an open command. The closest we have, this opens us, it looks on the hard drive over here. It looks on the hard drive for temp.txt, and if it doesn't find it, it creates it. If it's one there, it already uses it. Well, I don't think there's one on my drive, so it should make one. In fact, let's name it temp booger. I know there's no temp booger on my disk, so now it'll make one. So we're making a file from scratch. Well, with mem, you have a few different options with it. Right here, I'm going to tell it I want a new mem block. Now the difference is I need to specify how big it's going to be. On your hard drive, on the left, when you open it for binary, it just prints to it until you run out of disk space. Well, you don't want to use up every drop of memory you have, so you need to have an ideal. How much memory do I need? And for this demo, I don't need a very big mem block. 10,000 bytes. And as you can see down here, it says, okay, we've now got a memory block of 10,000 bytes. Here we've got a temporary file called temp booger, which is file F, and over here we have a mem block of 10,000 bytes, which is M, as we defined above it. So at this point, we now can check to see what the length of each file is. Well, here on the left, the file is going to be the length of F. Length of file, LO file, F. Now, the LOF command is how we learn the length of a binary file. Over here on the right, we have something very similar, but it's simply m.size. Use your variable name, and just like with any type variable, you just put the period and a dot size. And when we run these two, we should see, temp booger.txt is 0 bytes. I haven't put anything in that file. Now, over on the right here, when I compile it, m.size is 10,000 bytes. I've reserved 10,000 bytes for memory. So, m.size is the size of our mem block. LOF is the size of the length of the file. They're very similar commands in makeup. So at this point, nothing's really different. Now, here on the left, I'm going to put something in the file, so we finally have something in it. We put in number F, starting at position 1, and I'm going to put just junk. Now, junk string by itself is blank. It's nothing at this point. So if I run it, I'm putting nothing into the file, so I'm going to have a file with nothing in it. So let's put something in junk string. Hello world. Now we have a string, and we're putting it in the file, starting at position 1. So, position 1, this would be, the H would be at position 1, the E at position 2, 3, 4, 5 for the hello, 6, 7, 8, 9, 10, 11. So we had the first 11 bytes of this file is going to be hello world. Over here, it's the same thing. Junk string equals hello world. The only difference, instead of put, we memput. And we don't put it in F because we're not referencing F. We're putting it in M, which is our mem block. And then I've always thought that this point was kind of a little redundant and wasn't necessary. But we have to tell it, put it at m.offset. That m.offset basically says the start of the file, wherever it's located in memory. I don't know where the program's putting it in memory. It's somewhere. I've got 32 gigabytes of memory on my computer. It's in there somewhere. I don't know where it's at. I'm trusting Windows and QB64 and C and the programming environment itself to put it somewhere safe where it's not used. Well, where it starts at is m.offset. So this is the start here, just like byte 1 is the start over here. And then we just put junk string. Well, now we got junk string in both directions. So hello world is now going on the disk here. Hello world is now going into memory in our mem block M as we specified here. It's not complicated. If you can do binary file access, you can do memory access. They're set up very similar, very same patterns of commands. So now let's make a temporary string, and we want it to be 5 bytes, 5 spaces. We're going to do this for both programs. And we're going to now get this temp string from our drive, starting at byte 1. And over here, we're going to mem get it. And then on either side, we're going to print the file. And when we run them, what we should see, hello. And over here, what we should see, hello. Hello, hello. Same thing, both sides of the files, same positions. Now if you notice, over here on the left, I made certain to specify my file position. Now sometimes people will take a shortcut and they'll leave this blank, which says get it and then get the next byte, then get the next byte. Well, mem doesn't have that option. We have to specify the byte that we want to get. So, since I'm specifying the byte in mem, I wanted to specify it for the binary access as well. So, and to show that it works, we'll just get the 6th byte. And if I can type, which half the time I can't, so that's nothing new. And now, when we run it here, byte 6 starts at the space, the WRL. Well, why does it start there instead of at the W? Because we start counting with 1. Over here, you'll notice that we actually have hello world. We don't have hello with a space in it before the world. Hello space world. So, what's the difference? Our beginning offset. The offset on the left begins with 1 for binary file access, where I've got the cursor highlighted right now. You can see the 1. That's the first byte for file access. Well, over here our first byte is m.offset. Well, 6 is only 5 bytes over from 1. So if we start counting up here, see my cursor? Hello, that's 1, 2, 3, 4, 5, 6. This puts us at the space. This is what we'd expect. Well, over here we have m.offset. And if you look at the H, that's m.offset. m.offset plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. So, when you're working with memory, you have to remember the one difference between it and binary access files is the beginning offset starts at 0. m.offset starts at 0. Binary files start at 1. So you may need to make a slight adjustment in your programs to make up for that difference. In this case, it's just changing it from get number F6 to byte 7. Hello world. The W starts at the 7th byte, and over here it starts at m.offset plus 6. It's at 1 byte difference. It's just our starting point. If you start an array starting to count from 1 to 10, or if you start an array from 0 to 9, they both have the same number of elements, but the offset's different, the starting point is different. Well, binary files have a starting point which starts with 1. Memory starts at 0. And why the people who decided to do this did it like this, I don't know. I didn't make the specifications. I can't tell you what they were thinking. Somebody decided that files should start with the first byte, and somebody decided memory should start with the 0th byte. And that's what they do. So, that's the main difference between the very basics in these two commands. And when we're finished, we close our file. And when we're finished over here, we free our memory. And that's the basics of the two commands. That's how similar they are. There's no great mystery to it, no great puzzle. If you can work binary file access, you can work memory access. And I'm going to stop the first tutorial here, and I'll upload it to YouTube, and I'll share it, and I'll let people take a bit to look at this and compare the two programs side by side, and take a bit to test things on their own. But really, this is how similar the two commands are. If you can work with a binary file, you can work with memory. That's all there is to it. And I'm going to go ahead and stop my first tutorial here, and I'll post it, and we'll see if anybody has any questions or problems with it. And then later on I'll go on and I'll show how we access variables, or how we access images and such to work with them with memory. But for now, this is the very basics of the difference between the two, and it's not much. If you can work with the binary file, you can work with memory. So, good luck guys, and I'll post another tutorial shortly for you. Thanks for watching.